This is my crazy 4th hour. You can hear there's no control whatsoever. Nothing. Bunch of animals. Silence. Speaking of animals, look at that equation up there, and those that looked actually solved it already. Okay, so X equals a live skunk. So is this mathematics? Did you divide by horse or anything like that? And I can't erase anything. Maybe it's just stuck in there. All right, but anyway, you know, and I felt bad about maybe 3-5 being a little bit of a challenge, so I thought I'd just kind of start off with quick 3-5 notes. If you want to take them down, I'm not going to give you much time to do so, though. So, may throw out some questions you might have had in the homework from last night that can be challenging, but not too bad. All right? So, first things first, as I say almost every day about 5 times. Okay? When you have an exponential scenario, if you can get equal bases, then you should do it. That's that first example on the left. And then use horse times skunk equals horse times X technology. All right, which means I just use simple matching to say, oh, if 3 to this power equals 3 to that, the only way that could be true is if this equals that. So 7x must equal 5 in this scenario. You didn't do any math. You didn't divide by 3. You didn't use logarithms. You just used that horse skunk X thing. But then on the other side, sometimes you have things that, well, 50, I can't write that as 2 to a power. So that one you have to use the glory and power of, anyone? Logs. And we'll get that popping up like 5 times. So, oh, and by the way, should I be taking 20 times 2 on this second one right here and making this 40 to the t? No. There's many reasons why that's bad, but the main one is PEM. Anyone? Yeah. So you really can't multiply before you deal with that exponent. Trying to solve for that exponent, so 20 should not be incorporated in that exponent. Then another one, believe it or not, this one can be rewritten in similar powers. Can't take 20 times a half. You've got to divide by 20, and 1/2 and 1/4 can be written as equal bases. So this would be the kind of question on a no calculator portion of the exam. You got it? So that's what you're expected to do. So I said someone to remind me, but you know what? We're going to make this up. I didn't do this second hour. They hate me anyway. So let's just move on. 3 to the 2x plus 5 equals 7. Oh, I'm just making this up. 7 to the 4x minus 3. Oh! First of all, 3 and 7 have common bases? No, so this is not getting equal bases, drop the bases. So with that being the case, you have to use the glory and power of logs. Ooh, I just had a great idea. Let's add this. No, forget it. All right, here we go. So you have 2 choices. 2 choices. One is, this is the what? This is the what? What does that leave then? This all represents the what? You got to do it. Or, and it doesn't matter which way you go, this is the what? Base. This is the what? Then this is all the what? And then because I don't want to recircle and erase, I'm tired, I'm just going to stick with that one. Log base who? 7 of who? 3 blah, right? 3 all of that. Equals what? 4x minus 3. Okay, and then you know what this actually just becomes? After one rule of logarithms, it just becomes an algebra 1 / algebra 2 decimal equation. That's why I get sad students that aren't able to handle this, you know, going next. But you know what? We're in honors. I'm going to leave this also in calculator-ready form. I'm going to get this to say x equals and then a whole bunch of crap with logs in it. And then we could go to the calculator and type it. But I'll also reference how you do this easily. So what's the one rule that I need to use to you know, get this moving? I need one more logarithm rule. Yes, ma'am. Okay, so what did you say? I just got an email and I wasn't listening. I'm sorry, I was looking at it. This is about a student. So what do I do? You have to put the 2x. That's what you said. I thought so. You know, at least I don't lie. It wasn't great what I said, but I'm not a liar. At least in this case. Anyway, What? Let's move on. Okay, now, let's be honest. You could get this to be a what right now? You can get that to be a decimal, and then you could distribute the decimal, and then you just have a decimal equation, get the x's on one side, the non-x's on the other, and divide at the end. But what we're going to do is do what used to happen back in the day, complicated, wow, the brain's not firing right now. Exams that students take to get into college entrance exams. Okay? So a lot of those are multiple choice, or, yeah, they're multiple choice, and you have to have it in calculator-ready format, so you got to leave the logs alone. So let's distribute that log as it is. Oh, the second hour missed all this fun. 2x log base 7 of 3 equals 5. What? Plus 5 log base 7 of 3 equals 4x minus 3. And then the reason this is, it's kind of a pain, but it's still okay. What are we solving for? What variable? Say it. Say it out loud. X. So whatever has an x, I got to get them on the same side. So the next thing is to, oh gosh, sorry. And then minus 4x, and that equals negative 3 minus, right, 5 log base 7 of 3. Correct? Then, how come I got these on the same side? So I can do what? You're actually just 2 steps away. What am I going to do with that x that they have in common? Factor it out. I thought I gave you a clue. In common. This is called a common factor. And then because of time, you can divide both sides by that set of parentheses. And then that's what x equals. Fine, I'll write them here too. Okay. And then this would be called, put this in parentheses as well, calculator ready format. All right? Or at the very beginning, you could have got this to be a decimal and then just dealt with a decimal equation. I don't care either way, but you should be aware of how to get those in that format. And that's what x equals, because this cancels here. And then you could go to your calculator, use the parentheses. Unfortunately, if you don't have an upgraded calculator, how do you do log 7 of 3, log base 7 of 3? Change of base. Okay? All right. Okay, back up to basics. If I have an exponential, change it to a, unless I can get equal bases. If I have a log, change it to a exponential. And that's why this should not have been hard, most of your homework. So I don't think you have to write these down. Just look at what I call example 4, then all of a sudden I lose my numbers. But what you need to do is isolate that logarithm first before you start changing a log to an exponent. And you can't have a negative in front of a logarithm, so divide by a negative. And then turn it into an exponent by our logarithmic definition. Same thing with this one. And do check your answer at the end. What's a negative 10 squared, though? What's a negative 10 squared? So I'm checking that quick, easy, simple answer. And then I felt bad that we didn't talk about this. So we'll zoom in on this if you want to take that note. Because actually I did not have this on the trail or the domino. So here's one example of solving a complicated logarithm. By the way, you know, it does go back to horse times skunk equals horse times x rule. But it's not the starts. And I actually had someone do this. If you drop your logs early, you're going to make a mess of the situation. So what you have to do on the left side is use the sum rule, which means 1 log, 2 logs, turn into 1. A sum means multiplication. So ln of this plus ln of that means ln of those two things multiplied together. Now I have ln equals ln. The only way that could be true is if this equals that. I didn't do anything mathematically other than just drop the ln equals ln part. So that's horse, skunk, x. And then you solve. Now as you look at that and look at the answers, why did I cross off a half? Why did I cross off a half? Go ahead, sir. It's extraneous, but I need more. Why is it extraneous? You plug it in here, you get 1/2 minus 1, which is ln of a negative, which ln of 0 and ln of negative numbers is not possible. So that it is an extraneous solution because when you plug it in. By the way, what is the domain of this situation? That's a good little question I'll put in a movie. Well, you have to look at all three of these. What does x have to be here? X has to be what for this one? Greater than 0. What's x have to be here? Greater than what? What's x have to be here? Greater than what? 2/3. Which one's the most restrictive domain? The x greater than 1. So the domain of this is 1 to infinity. So x could not equal 1/2. That's how you find the domain of a logarithmic situation. All right, shove it in the face, kind of a note, because this was from yesterday's homework. But notice the subtraction of two logarithms turns into 1 log of divide these two things. X divided by, oh, by the way, one more rule, power, then divide. And then 1/2 power means square roots. And then this one's different than the last one. This is not drop your logs. This is turn 2 logs into 1, and I only have log of this equals a number. So that is turn a logarithm into an exponent. So you better be careful. There's 2 different ways to approach logarithmic equations. One is turn it into an exponent. The other one is log equals log. Drop your logs. And then you can see the mathematical situation after this. All of this is algebra 2. All of it. But remind yourself by taking the notes down that we cross multiply. To save a square root, we square. You also square the 10. This is a product raised to a power. So you square the 10 as well. And then it becomes a nasty quadratic formula. So as you're writing this down, it's obvious. Why did I knock out negative 3.85? Because when I plug it in, I get log of a what kind of number? Negative. So you got to be careful even on the quadratic formula ones that you actually check for extraneous solution. Okay, before we get into actually a little bit more 3.5 and 3.6. So this is really what it comes down to, and this was at the end of your notes, yesterday. If you have b to the x equals b to the y, then x equals y. It's not math. Horse, skunk, x. Log of x equals log of y, x equals y. Horse, skunk, x. If you have a log, change it to an exponent. You have an exponent, change it to a log. And then number 4 is actually number 1. But you might have to do number 4. Actually, number 4 could turn into either 1 yellow or 2. But if you have more than one log on one side of an equation, use the sum difference rule and then actually the exponent rule. I think you're fine on that.